Okay, let's just jump right into this explainer. We are looking at an absolute masterpiece today. But this one isn't hanging on a wall in a museum. It's literally suspended deep in the pitch black canvas of the cosmos. Today, we're exploring the majestic Bubble Nebula, and we're going to unpack exactly how such a delicate, almost fragile looking structure is actually forged by some of the most violent forces imaginable. So, when astronomers peer into the void, they see these incredible, nearly perfect spherical shapes just hanging out there in the darkness. And it really makes you wonder, right? What could possibly blow a cosmic bubble so massive that it spans actual light years across, all while sitting a staggering 7,100 light years away from us? It's a question that practically begs us to look closer at the raw mechanics of the universe. Well, when the legendary Hubble telescope turned its gaze toward this specific region of space, it captured something wild. A super hot, massive star seemingly trapped inside a giant glowing bubble. This astonishing structure is what astronomers call the Bubble Nebula. But to understand how it got there and how this star basically got enclosed inside its own creation, we first need to take a quick step back. Part 1. What is a nebula? Before we unpack the bubble itself, here's a quick refresher. A nebula, which actually translates to cloud in Latin, is simply nature's swirling mix of raw materials. It's an enormous interstellar gathering made up mostly of dust, hydrogen gas, and helium gas. These vast clouds are the structural cornerstones of our universe. They're dual purpose, too. They're both the lingering, beautiful remnants of dead stars and the fertile nurseries where completely new stars are born. Now, these cosmic clouds generally come in three distinct forms depending on how they interact with stellar light. First up, emission nebula. These have high-temperature gas energized by stars, so they actively glow in rich reds and pinks. Then you have reflection nebulae, where the dust clouds just scatter a kind of ethereal blue light from nearby stars. And finally, dark nebulae. Here, the dust is just so incredibly thick that it completely blocks out all the starlight from behind it, creating this striking dark silhouette. So our target today, the Bubble Nebula, is an emission nebula. That means it actively glows because of the intense energy trapped inside it. It's absolutely packed with high-temperature gas. But it doesn't just magically glow on its own. It's being constantly energized and blasted by intense ultraviolet light from a source deep inside. That energy is what transforms a cold, dark interstellar cloud into a vibrant, glowing masterpiece. Think of it like a giant cosmic neon sign buzzing in the dark, driven by the intense radiation of young hot stars. It's basically electricity and gas interacting on a galactic scale, which creates this luminous, colorful beacon piercing right through the deep space darkness. Section 2. Finding the Bubble Nebula. The Bubble Nebula, officially known as NGC 7635 if you're checking astronomical catalogs, is located an astonishing 7,100 light-years away from Earth. Let's just process that immense distance for a second. The light that our telescopes capture today, it actually left this nebula over 7 millennia ago. We are literally peering deep into ancient history every single time we observe it. If you were to step outside tonight and look up toward the Cassiopeia constellation, that is exactly where this giant structure is hiding. It sits right on the border with the constellation Cepheus, forming this incredibly rich, dense field of deep space objects that astronomers just love to study. Now, the engine actually driving this incredible nebula is a massive central star that burns a staggering 1 million times brighter than our own sun. Let that number sink in. 1 million times brighter. That is an almost incomprehensible amount of energy. And it's that specific, highly localized intensity that's directly responsible for blowing the cosmic bubble we're looking at today. Section 3. The stellar wind mechanism. At the absolute core of the Bubble Nebula sits an extremely large, exceptionally bright Wolf Riot star. This specific type of super-hot, massive star is an absolute powerhouse. It's throwing off mass at a crazy rate, generating the immense power and radiation needed to literally carve out the surrounding space and forcefully push everything else away. So this formation basically happens in 3 steps. First, you've got this super hot, massive Wolf Riot star burning intensely at the center. Second, that extreme heat and radiation release fierce, high-velocity stellar winds. And third, those incredibly fast-moving winds violently slam against the surrounding cold interstellar gas and dust. It's a continuous, epic collision between the star's explosive energy and the freezing, dense material around it. Section 4. The Cosmic Soap Bubble. To really visualize this,
Think about blowing a regular soap bubble in your backyard. Your breath pushes outward against a thin, soapy film to create a delicate little sphere. Well, the Bubble Nebula works the exact same way. That hot central star acts just like your breath. Those fierce stellar winds push outward against the cold interstellar medium, expanding it into a massive, glowing shell. The mechanics are beautifully similar, they're just operating on a scale of trillions of miles. Now, sources constantly refer to it as a delicate soap bubble, but we have to remember that in reality, it is incredibly violent and vast. You're looking at a region of chaotic thermal shockwaves, constantly sweeping up material into an ever-expanding, glowing shell. So yeah, it looks totally serene from afar, but up close, it is absolutely furious. So bringing it all together, the interplay between that central star and the surrounding dust gives us these breathtaking visual elements. You've got the swirling clouds of glowing gas. You have that super hot, million times brighter Wolf-Rayet star running the show as the engine. You have vibrant, neon-like emissions caused by all that ultraviolet radiation. And finally, you get that delicate, curved, bubble-like outer structure forged by the stellar winds. Together, they create a perfect cosmic storm. Which brings us to our final thought for this explainer. If a single star can blow a cosmic bubble so incredibly vast and beautiful, what other masterpieces are waiting out there in the dark? It really leaves us wondering about the universe's limitless capacity as the ultimate artist, and exactly what breathtaking canvases we might discover next as we continue to look up.